Okay, folks, welcome back. Now we are going to record or we are going to present you the session. This is the first time you are looking at this ship. Again, like the other ships, I must give you the familiarization of this particular ship or vessel gas carrier. So far, we have worked on the Type B and Type C tank, which is can sustain certain pressures. This is the Type A tank, it is the membrane tank, which has got a complete secondary barrier, and the tanks from inside are very thin, but the good thing is that they are prismatic tanks. You can see inside the tank, I've created this exercise so you can see that has got a 5.2 kPa pressure inside the tank. What we have done so far with this one is that we have gone through the drying process of the tank. So currently you are looking at the status page where we have got the electrical emergency shutdown condition, optical, pneumatic. You may notice that we have managed from the engine room to cancel all the alarms, so we are fairly active and we are at the moment again on the berth where we are. You can see that we have stabilized this vessel. Our forward draft is 10.5 meter 54 and we have got 10.5, no list, and our vessel is fairly even keel with 1 centimeter trim by this stern. The flow rates here, all manifolds are 0. Ship whistle is on, general alarm, water curtain is on. Because of course we are standing by on the shore, so we always keep the water running. A ventilation room motor is switched on, machinery room motor is switched on. This is what I have done during the creation of this exercise. The other environment is that wind speed is about 18 knots, 180 degree direction, 23 degree air temperature, and hydraulic system is working, so there is no alarm on hydraulic. So on our next page, where you will be able to see my cursor, that there is a fixed gas detection alarm. So let's go and see what is that alarm for. And it is fairly obvious that there is a low flow alarm in the gas analyzer. So means gas analyzer motor has tripped and there was no gas analyzing is happening. So all these gas detection points are not really in operation. So what I will have to do is that we will put it on. First, of course, we will acknowledge the alarm, and as soon as we acknowledge this alarm, of course, we should have this thing stabilized. Then we'll put it on manually, and we should switch on the pumps. And did you notice the moment I have switched on one pump, the low flow alarm has gone and my gas detection alarm has now cancelled. Fixed gas detection. Now our fixed gas detection is in operation on manually. Normally we put them on auto, so we'll put it on auto mode. Now the gas analyzer will automatically keep on working while we are working on this ship. Time to time we will come to this control panel to verify if there is any alarms, but if there is any alarm would be showing up here, it will be automatically reflected here on the top with the red light flickering. Now, let's go to the portable gas detection. What we have done, now you will see a different characteristic here. Now, we have got interbarrier spaces, insulation spaces, IBS and IS here. The rest is almost the same. So at the moment we are sniffing here, and we are detecting. What we have done with this tank is that we were removing the moisture from the tanks in the past exercise, and we have managed to remove the oxygen, and we have managed to bring the dew point temperature to minus 26.8, which is fairly good. So at the moment I am analyzing manually the top of number 4 tank. Let's go and see the middle condition of number 2 tank. So I will switch on this thing, and of course in between any analysis, what we do is we purge it with the air. So we have now purged it with air. It is showing 20. Once we have purged it with the air, as soon as the air is off, we are going to start our analyzation of this tank, and let's see what will be the result. Yes, the environment here is also minus 26. Here the minus 37.8, which is ideal, or which is coming. Well, let's see what is the bottom status. Bottom status is also the same. Purge it now. And say we are purging it with air. It will automatically switch off after purging. It has indeed. Now I will choose. Let's see on the bottom part of number 2 tank or number 3 tank, and let's do the analysis of dew point. You see here the bottom dew point is 26.0. So folks, you have now noticed that different places we have got different level of dew point. And of course, what is our job is to keep purging, to keep removing the moisture till the time we have the dry air. So that was our portable gas detection system. Cargo pipelines, yes, rather than our spherical tank, we have got this type of arrangement here. Because we are taking the air from it and drying it, we have dried it. So we have built a little pressure in the tank because we were blowing dry air into the tank. Okay, and of course this is our pressure, 5.2, and the temperature in the lines of the vapor is about 20.1, 20.3, etc. So you can see that there are no alarms here. Everything is in order on the cargo pipeline system. Let's go to the manifold area. Manifold area, everything is on order. All blank are in place. The outside temperature is about 22.8 degree. Here we have slightly negative pressure. Maybe it is because of shrinkage or cooling or something. Then rest all are 0 kilopascal pressure. All valves are closed. So we are happy about it. Now let's go to the cargo tanks. In the cargo tanks, you may notice that this is red. It is not flickering where my cursor is. It is not really flickering, but it is steady red. And why it is? Because it was when we switch off the pump last time after pumping it out, the low amperage alarm has come and that is still standing by. Now this is the temperature reading in our tank. In the trellis of this tank, we have, especially in in the custody transfer system, we have multiple level thermometers, and those thermometers will give us the temperature at different. So 21.2. Can we load the cargo in here? Not at all, because there is oxygen in the tank, and there is also the the temperature is not on a cryogenic level at the moment, so we'll give a thermal shock to the tank if we start loading the cargo. And of course, we never want this situation. So our tanks are technically dry, but we have got the air pressure of 5.2 kilopascal, and all our pumps are technically stopped. So those were our cargo tanks. We were at the moment looking at number 1 cargo tanks. We can go to number 2 cargo tanks, and more or less the same situation is there in all the cargo tanks. Okay, let's move on to the machinery space. What is happening there? The discharge side valve of the HD compressors are switched on, clear, so that there will be no pressurization within the if there is anything evaporating in there, so there it will not be pressurized only in this area, it will be just going out everywhere. Then there is not a significant alarm here on this particular unit. Then of course our HD compressors, this is the magnifying situation. It has got couple of alarms where we have got a low level lube oil pressure alarm, which of course will be there because we haven't started the pump, but when we start this thing we will talk about it later. No, so we have got nitrogen seal alarm, which will acknowledge, and of course we will send the nitrogen to it when it will be required. Okay, so but of course you will have to run. So did you notice the moment I have started the nitrogen supply to the compressors, that alarm has gone. Only the low lube oil pressure alarm is coming, which we need to see. And now you can see the nitrogen is supplied to the compressor with about 789.8 kilopascals. All right. So this lube oil pump will sort it out when we'll start the compressors. So control air pressure for these compressors are about 800 kPa, which is good enough. But their pressure in the lube oil is low. So let's move on now. We can see HD compressor has got a steady light on it, not flickering like the LD compressor. So we'll go to the LD compressor. Again, more or less the same situation here, where we need to give supply of coolant and this thing here, and of course we will have to give a nitrogen supply. Can you see it was on 0 and now suddenly it is rising. The moment it will rise, the nitrogen alarm or the low pressure alarm will go from. Happy folks? Now again there is a low lube oil alarm, so why not start a low boil pump. So my last alarm will go off. So let's acknowledge the alarm. And now you can see the light has become steady. Let's see the heaters. The heating system, of course, at the moment is totally closed. There are no alarms and it is fairly okay. The vaporizer, again, we are not vaporizing anything. So there are no alarms here and everything is secured. Now let's go to the engine room where there may be some problem. We have got our nitrogen generator running, creating nitrogen, filling the buffer tank. The buffer tank is feeding our systems of different compressors, etc., etc. So this is the compressor line which was going there, and of course to the other pressurization headers on the deck. So technically our buffer tank has got 794 kilopascals pressure, and O2 content is 2.05 in it, and dew point is -61, which is better than ideal. So our nitrogen we have got so far is a very good quality nitrogen produced by our own nitrogen generator. If we were ever short supply of nitrogen, or when we need more nitrogen, we can comfortably put another pump on a standby nitrogen generator and switch on as required. At the moment I do not require another one because I've got sufficient pressure here. So we will continue with this and folks, take a break. Hello? Yes, speaking. Yes, folks, I had to attend the alarm. So I managed to do that. Now can you see we have got an O2 content alarm in inert gas system. So of course the O2 inert gas system we are not using. So we are expecting that alarm because our inert gas is running, our boilers are running. We are with the and it is all operational. So what we are now going to do is run an IG generator to supply the gas into the tank, inert gas into the tank. We have already done the drying of the tank. Our dew point is well below. Some tanks we are well below 40, some tanks we are still drying it out. So we will come back to this engine room again to start our inert gas plant. This is our nitrogen supply to inter-barrier spaces, or you can see the nitrogen is going there. They are all pressurized, 0.8 kPa. Inter-barrier space or space is also 1.2 kPa. In it, our tank dome also has got the inert gas supply in it. So technically nitrogen supply in it. Technically it is all working well. The nitrogen generator is working on automatic, filling the buffer tanks and giving the supply. Did you notice this valve is half open? So moment we have got a lesser pressure in a tank, can you notice? Interspace pressure 1.5, 1.5, 1.5. But here what I have done is I have introduced a leak into the system through the simulation system, and now you see the pressure has dropped, and the valve here will be automatically opening and will be filling it up. Sometime we need to open the valve manually to fill the space. So I'll leave it on automatic, and let's go to the glycol. Glycol system is used in the cargo system. For the glycol has a quality that it will not freeze under sub-zero conditions. So this is the whole unit or supply system. So at the moment there were few alarms because it is not operational, so we'll not go in detail at this moment. In here, this is our lube oil system, which you remember the lube oil system was showing a kind of failure where there was not enough supply going on. So we will start the lube oil circulation pump, and the lube oil will automatically build the pressure. You can see the alarm is there, and you switch on the cooler and let the supply of it begin. Folks, we are not starting at the moment the steam because our purpose of this exercise is to inert the tank. Again, I'll come to the ballast page. In this one, we have got certain alarms, which of course we will acknowledge. Here you will see there are different system of ballast tanks, but we managed to fill this one partially, fill the after peak full, and all the rest of tanks in full position except this tank, which is partially filled, and 4 peak tank empty, and we have managed to achieve our objective of maintaining the 10.54 meter forward and 10.55 meter aft. This is again our ancillary tanks information, what we have got in which condition. So now let's go to the engine room, because this is the only thing which is flickering at the moment. So we are going to start our pump, and we need to give IG to the tank. So what we need to do is, first we will have to see the IG lines, the purple lines. So let's go to the cargo pipelines. This purple line is coming from there and going in the tank. What we have got? An air in the tank. What we need to take out? Air. What we are replacing it with? Inert gas. Where we are going to put the inert gas? Top or bottom? Tell me. Yeah, bottom, of course, where you are introducing the gas, heavier gas, inert gas from the bottom, and air will automatically go up. So first thing, we will prepare for the air to go out. We can easily throw the air from the moisturizer. So we have got the common moisturizers, or we have got the individual PV break. So let's open the moisturizer valve, but from here, let's open this valve. Now, is it connected to any tank? We'll have to see. Can we connect it to the tank through any other means? Yes. It is connected to the tanks from the tank dome, and it will take out our air from it. So the way of going out of the air is already arranged or settled. Now what we have to do is we have to vent out we will have to put the inert gas into the tank. So we have decided that we are going to put it from the bottom. So we have two choices: either use this line, condensate line, to put it from the bottom, or we can even use the liquid line. So let's open the liquid line for all the tanks. And it will give the gas, release the gas at the bottom of the tank. So now all these valves are open. So what is the second valve? We'll open that valve as well. So let's check. This line need to be connected to this line. Okay. So very simply, we'll put any spool piece in here. We will put another spool piece in here. And now you will be able to see that we will get the inert gas from here. We will pass it to the liquid line, or open this valve, and now we can take it to the bottom of the tank. So on the deck side we are okay. So now the second task is to start the inert gas plant itself. So we can see there is low seawater flow now. Yes, it needs a water flow in it. So we will have to start the water flow. From where this water flow comes? From the saltwater ballast line. So let's go to the ballast system and give the water to the inert gas generator. Put the line here, spool piece here, open the valve, open the C-section. So the water is coming from the sea chest, going in this direction. So now this is connected to inert gas generator. The lines are here. The liquid is filled here. Can you see? Because of the liquid level water coming here, there was a very slight discharge pressure. We will put the pump on standby. We will inform our engineers down there that we are about to start the pump, so they are able to give us the supply of let's open this valve, crack open discharge valve, and now run the pump. You see, very high ampere gone, discharge pressure has built, the pump is running, the discharge pressure is high, so now we can open the valve further to reduce the discharge pressure. We can comfortably open it fully. Now, because the pump is not hunting, the amperes are stabilized. Now this water should be going to the inert gas plant. Let's see. It has now, the water has come here. Now the low seawater flow alarm has gone. Magic. Now the only alarm left is the O2 content. Yes, O2 content is high at the moment because it is filled with air. So we'll just acknowledge them. And of course, when the inert gas start passing from here, then it will be stabilized. Now you will see at the moment we do not have any alarm in engine room. Just, it is steady. Now, once we have started the flow of liquid, now you can check the line, and I'll take the control on the panel. Hello.